Alright, this is dimensional analysis part 1. And what dimensional analysis allows us to do is take those equalities or those equal signs that we've been working with and use them to solve problems. So we can use any known equality in a dimensional analysis calculation. Sometimes you'll hear us refer to dimensional analysis calculations as conversion problems. Two key steps. We're going to start with the units we know. You often hear me refer to that as the starting point. Then we're going to go out to the far side of our problem and list the units we are trying to get to. So we'll do 3 examples here. So we'll start with one where we have a conversion factor. We're probably familiar with it. We're looking for how many inches in 2.56 feet. Well, alright, the units we know, or the starting point, we're starting with 2.56 feet. We're going to put that over the number 1. That number 1 serves as a placeholder. Way out here, we're trying to get to units of inches. We know the equality that we're going to use in this problem. Well, we know there are 12 inches in 1 foot. Every time we do a conversion factor problem, we generate these bars, and every one of these bars is generated from an equality. So in this case, we know that we have to cancel out units of feet. So we're going to put feet on the bottom. Because we have feet on the top, we want to get feet on the bottom. We're going to put inches on top. Once we know for certain we have our units correct, we're going to put the numerical values in. There are 12 inches in 1 foot. At this point, units of feet will cancel out. And I'm ready to use my calculator. Some general rules for dimensional analysis with your calculator. We're going to start with our first number. We are going to ignore all of the ones. Meaning this number down here, we said earlier was just a placeholder. This is like 2.56 divided by 1. Well, we still get 2.56. We're good. Our third rule, as we progress through our problem, is we are going to multiply if our subsequent or our next value appears on top of the problem, we are going to divide if it appears on the bottom. Our fourth rule is we are going to hit the equal sign after every step. And as we are asked, we are going to include units, significant figures, and when it makes sense to represent numbers this way, scientific notation. So following those 5 rules in our attempt to go from feet into inches, it also helps to have an idea. We have 2.56 feet. We know there's 12 inches in 1 foot. Our answer is going to be bigger. This is a multiplication problem. So our first number is 2.56. We have this 1 underneath. We're going to ignore it. Our next subsequent value is 12, and it's on top. So we are going to multiply by 12. And we're going to hit equals. We get 30.72. This number 1 is on the bottom, so we can also ignore it. So our initial answer is 30.72. We're going to respect significant figures. So in our original problem, 2.56, that had 3 significant figures. The 12 and the 1, those are counting numbers or definitions, so they have an infinite number of significant figures. So recall from earlier, our answer has the same number as the least amount that appear in a problem when we were doing multiplication and division. So we have 3, infinite, infinite, infinite. So our answer is going to have 3. So we're going to take the 3, the 0, and the 7. We're going to ask ourselves, does the 2 round the 7? In this case, no, it doesn't. So we're going to get 30.7. And if we wanted to go ahead and put that into scientific notation, we would have 3.07 times 10 to the first inches. We'll do one more with units that we're a little less familiar with. And in terms of these equalities or equal signs, they always have to be available to you. So this 12 inches equals 1 foot thing, we might have known that, or we could have looked it up. This next problem, we're going to set you up in a situation where you're definitely going to have to look up the equality to use in the problem because we don't know what that is most likely yet. And that problem looks like this. We're going to ask how many grams in 5.74 times 10 to the 8th micrograms, abbreviated UG. So same way, we start with our starting point. 5.74 times 10 to the 8th micrograms. I'm going to go ahead and put that into parentheses because I'm always going to do that on my calculator. When I have to put scientific notation in my calculator, I'm always going to use parentheses. We're going from micrograms into grams. We set up our dimensional analysis bar. We are going to place micrograms on the bottom and grams on the top because we want microgram units to cancel out. From here, we need an equality that gets us from grams to micrograms. And at this point, we probably don't know. So this is where an outside resource is going to come in, or a list of conversion factors are going to come in and be helpful. So after looking it up, we know that there are 1 times 10 to the 6th micrograms in 1 gram. And again, you would not be expected to know that. That's a value or an equality that's going to be in a table, or we're allowed to and need to look up. So once again, we're going to use every conversion bar is a complete equality. We're going to place 1 times 10 to the 6th micrograms on the bottom and 1 gram on the top. Micrograms are going to cancel out. I'll also go ahead and put this into parentheses for use on my calculator. At this point, we're ready to run the problem. We are going to start with our first number. All calculators are a little bit different, but here we go. We're going to go parentheses, 5.74. In the TI-30XA, times 10 to the 8th is represented as the EE button. So this is times 10 to the 2 zeros show up, and we get 8. And we are going to close the parentheses. So in this case, the calculator had enough room to show the entire number, so it did. Sometimes it will not do that. We start looking at our numbers from there. We have a 1 on the bottom, so we ignore it. We have a 1 on the top, so we ignore it. Our next value is this number on the bottom, so we are going to divide. So we're going to divide by, and again we have scientific notation, so we're going to put it in parentheses. Parentheses 1 times 10 to the 6th. Now we're going to close the parentheses. So again, it showed us the number to its full value, and now we hit equals after everything we do, so we're going to hit equals. And so we get 574 on our calculator. Again, scientific notation now and significant figures. Our initial problem had 3. We mentioned earlier, anything we bring into the situation has an infinite number of significant figures because these are definitions. So our final answer is going to have 3 significant figures. Ultimately, as you move through your scientific career, we want to use scientific notation when it helps us. I'm pretty much comfortable leaving this answer as 574 grams, though if you are asked to put it into scientific notation, we're going to go 5.74 times 10 to the 2nd grams. And we're good. Notice scientific notation always reflects the same number of significant figures that were in the original problem. And that's dimensional analysis 1.